In this lesson, we're going to solve logarithmic equations. So we've been solving exponential equations, and we know that the inverse of an exponent is a logarithm. So in this case, we're going to start with the logarithm and ended up solving by using the laws or exponents. So I have an example, 5 plus log to the base 2 of 25 minus x. My argument is 25 minus x. My base is 2, and that's equal to 8. And we'll start with the first step. The first thing you want to do is isolate the logarithmic expression. Basically, log to the base 2 of 25 minus x. We want to get this by itself on one side of the equation. In this case, sometimes I'll have a coefficient in front. In this case I don't, but I do have a constant term that I'm going to subtract away. So if I subtract 5 from both sides, my log expression is now isolated. Log to the base 2 of 25 minus x, and that's equal to 3. So the next thing we do, now that it's in log form, I can't do anything else with this other than rewrite this as an exponent. Remember, this is your base, 3 is the exponent, and this is the argument. So that is the second step. We're going to write the expression in exponential form instead of logarithmic form. So that leads us to my argument, which is 25 minus x. It's going to be equal to 2 to the third. If you forget anything, this is what it's going to be. A lot of kids will just say 25 minus x is equal to 3, and you'll forget that you have to convert. You have to raise the base to the exponent for it to be correct. So we have 25 minus x, 2 cubed is 8. And it's just a coincidence that in the original we were originally equal to 8. And then the last step is to solve. It'll usually be, well, sometimes it'll be a first degree, sometimes it'll be a second degree equation. So if we solve this guy, if I add x and subtract 8, you end up with x is 17. Now before we can say that's our final answer, we do have to check for negative arguments. So that's the fourth step, to check for negative arguments. I can't have a negative value as an argument because I can't raise any base to any exponent and obtain a negative value. So in this case, we're good because if x is 17, 25 minus 17 still yields a positive argument. So that's my final answer. X is equal to 17. For this example, we have two separate logarithms, both to the same base. So I'm going to use the first law to write this as a single logarithm. And that's going to allow me to solve the equation. So I can now take these two separate and write them, put them both as log to the base 2 of x times x plus 7. And that's equal to 3. Log to the base 2, if I distribute, I have x squared plus 7x. Now I have a single logarithm and just a constant term, so I'm going to rewrite this expression as an exponential one. My base is 2, my exponent is 3, my argument is x squared plus 7x. X squared plus 7x is equal to 2 cubed. So I end up with a second degree equation. Quite often you will have a second degree equation when we solve log equations. But that's nothing new. We're going to put it in standard form and factor and set each factor equal to 0. So there we have that. X plus 8, x minus 1 is equal to 0. I'm going to move over here, and when I solve, I get x is equal to negative 8, and x is equal to 1. So now we have to check for negative arguments. If I substitute in negative 8, I have a problem. I have a problem in both places. That creates a negative value, and that creates a negative value, so he can't work. If I substitute 1, I'm good. So my answer is x is equal to 1. Now, sometimes I could have a negative value. A negative value here doesn't automatically mean it doesn't work. In this case it would because of that single x, but sometimes a negative value still works, and you always have to check. So we'll do another example that's pretty similar. We have log to the base 3, and log to the base 3 is equal to 1, so I'm going to use the laws to write this as a single logarithm. Log to the base 3 of x plus 3 times x plus 5, and that's equal to 1. What I have to do now is I'm going to multiply this out to get a trinomial. If you multiply that out and combine like terms, you end up with x squared plus 8x plus 15, and that is equal to 1. Here's where you're going to make a mistake if you make a mistake. A lot of kids will drop the logarithm and forget that you have to raise 3 to the first power. A lot of kids will just say x squared plus 8x plus 15 is equal to 1 and totally forget about this. So please remember, when you are converting, you have to raise that 3 to the first power. So this is equal to 3 to the first. And that's just a second degree equation again. So we're going to put it in standard form, and hopefully it will factor. What's that? 12 plus 12 is equal to 0. Factors of 12 that add to 8 would be x plus 6. That's a 6. And x plus 2. So I come up over here. My two possible solutions are x is equal to negative 6 and x is equal to negative 2. Now, just because they're negative doesn't mean they're not going to work. So if I substitute in negative 6, I do have a problem here, and I have a problem here, because that creates negative values. So he does not work. But if I substitute in negative 2, negative 2 plus 3 is 1, he's good. Negative 2 plus 5 is 3, he's good. So negative 2 actually works. Don't assume it doesn't work just because it's negative. Okay, we'll do one more example, and then we'll practice some more in class. Here we have logarithms on both sides, log to the base 2, log to the base 2, log to the base 2. Well, I'm going to use the laws to bring these two together. Since it's subtraction, it's going to be a quotient, log to the base 2 of x plus 1 over x. And that's equal to log to the base 2 of 3. If you have a log to the same base on both sides, you can set the arguments equal to each other, and you don't have to deal with the logarithms anymore. It's just like if you have the same base on both sides, we set the exponents equal to each other. So in this case, I have x plus 1 over x, and that's equal to 3. Well, to solve that guy, you can cross multiply, and I get x plus 1 is equal to 3x. And this becomes a very simple problem. And I don't know if you can hear my cat. That is my cat in the background. She wants to go for a walk. So we're going to finish this problem up. X is 1/2. We're going to double check for negative arguments. When x is 1/2, this guy is good. This guy is good. So that's our answer. And we will do more in class. And at this point, I have to go take my cat and dog for a walk.